2-meter iron rod. So the length of the iron rod is 2 meter initially actually, and in that case the temperature is 0 degree Celsius. Now temperature rises up to 10 degrees Celsius. In that case, the green dotted line represents the expansion. So how much the expansion here, del of L, that we have to calculate, as well as for the copper, it was initially 0 degrees Celsius and of course 2 meter, and the temperature rises up to 10 degrees Celsius. This amount of length enhanced or expand. So this is, let's say, copper, and let's say here iron, IR. One important data missing for iron, that is the coefficient of linear expansion. So alpha of Fe is equals to 11.6 into 10 to the power minus 6 per Kelvin, and the copper is given here. Anyways, let's determine first the linear expansion for iron. So del of L IR is equals to, the basic formula is, so the fundamental formula is L dot alpha and del T. So let's plug in all the value. So length is 2 meter, alpha is 11.6 into 10 to the power minus 6, and del T is 10 minus 0. So let's put it 10 degrees Celsius. So the final answer will be 2.32 into 10 to the power minus 4 meter, or we can convert into millimeter. So we could write down 0.232 millimeter. A very tiny amount of length will be expand. Anyways, now it's time for copper. So let's write down the basic formula for linear expansion. So subscript CO copper is equals to, of course, the length alpha, the linear expansion coefficient, and the temperature difference. Here only change will be the linear coefficient for copper, and length is 2, and this will be 16.7 into 10 to the power minus 6, and temperature is 10. So we have 3.34 into 10 to the power minus 4 meter. So we could write down 0.334 meter, pardon, millimeter. So the value of copper is compared to more than the iron, and we can make a comment here, like, or maybe a question asked like, how much percentage of enhancement happen within this two metal or comparison. Indeed, we could comment like 44% more expansion